I'm Pete Sharp with Emerson. I'm curious if you guys are starting to bring in other data like from the assets of vibration on rotating equipment, you know, maybe some of the device alerts that come from the smart devices. Are you incorporating that as part of your alert systems?
We're incorporating it into the analytics. Again, it comes back to that slide with Ted. Our direction is all data comes in there, whether it's asset management, vibration analysis, alarms coming from a control system, process variables, laboratory data, infrared spectral, mass spec, NMR. You don't know what Ted needs. And the answer is assume he needs everything. So we're creating an environment where all of that data is exposed through that data engine to let a person come in and point and click to select the data they want, and it comes back into the data structures that are required to go straight to reporting, straight to data analysis.
I'll just echo the same ideas there. Getting access to all this equipment health monitoring data, you know, the valves are smart enough to know now whether they have a fault or not. You know, heart data, this is all going to be very useful. We just need to make sure it's going to the right audience too. You know, the operator only needs to know of certain things that they can handle on their shift, whereas like maintenance teams can address things that'll be more of maybe a weekly maintenance plan.
The challenge for us, anyhow, and maybe you agree from ExxonMobil, is comes back to the vendors in the room and suppliers in the room. How are you setting your systems up to allow us to do that? How can we easily tap into your data to marriage it with something else that you haven't thought of yet so that we can really exploit it? We need your help in that, because in our companies, I'm sure ExxonMobil's the same, where you're not doing it, we have to do it ourselves, and would rather not do that. We'd rather you would.
Yeah, we had to spend some of our own resources figuring out from the system side just how to get the data information to flow into our historian. We typically calculate the alerts on a 1-minute basis, but we first need that access to that data in the historian.
Yeah. Okay.
Basically, when you started this project of alarm management and alert management, what was the driving factor? Like, you had upsets in the plant due to not managing the alarms, or how did you solve this idea to management? Because there is a significant investment in terms of money as well as the engineering hours of different disciplines. This is one question. The second is that we have seen most of the DCS manufacturers, they give the fundamental things in terms of presenting the alarms and disciplining the alarms, basically. But they don't give the features of a standard alarm management package in terms of analysis and presenting into reports and doing further steps, either in the alert direction. So what is the DCS? And also when you take the third-party package for alarm management and interfacing to the DCS, there is a lot of issues in terms of interfaces and reliability of interfaces, whether we can allow the alarm management to suppress the alarms in the DCS, writing back, all this stuff comes into picture. So do the DCS manufacturers have their mind to incorporate these alarm management and alert management features into the DCS as part of their configuration?
Well, that last question, I guess, would be best suited to Peter. I'll take the first couple. How did we get started and how did we sell this? In our case, we used historical data. I mean, it's very powerful when you think about it. Here's things that happened that we would rather have avoided, and use the context of that, because management relate to that. When something goes wrong or something was off, whether it's an event or quality, they relate to that. It's not conceptual. It's not a PowerPoint slide. They felt it. They knew the tie to the economics at that point. So by using that information as the basis to move it forward, to get started, and then after projects are done, to demonstrate it. Again, my earlier comment, lead by example. The most powerful thing is to show what was done and what came out of it. It's not to talk about what could be done. We tied those two together. And as far as what vendors need to do, I'd love to hear Peter's answer on this, because when it comes to alarm analytics in the Emerson package we're using, some of the base data and variables that we need to really study the process aren't there. We have to create those variables ourselves and add it into the database. Again, that would be an example where we'd like it to be part of the tool to begin with.
So did Bob give you a 20 to ask that question? Because he's been asking us for, as you can't tell.
I'll give you 40 if he fixes that for us.
For enhancements in those tools. First of all, I'd say kind of our guiding principle around all the alarm management tools and everything, and I'm going to get the number wrong, but it's the ISA standard on the alarming and tied in with the MUA standards. I can't remember the
100, I think.
Which one is it? 18. Yeah, okay. Is the standard that we've been using as kind of measuring our functionality against and making sure we're up against that. And we've actually been surprised because we're seeing that showing up more and more in specifications as all you owner-operators are asking for it. In the particular area of the analytics package that we're talking about with here, a lot of the discussions we've had, Bob, and as you already mentioned, about easier ways to get the data in and out. I mean, it's one thing to get the analytics and the statistics and all the technology to work right. We've had a big struggle just in deployment and how, as we've already both of you mentioned, in getting the data. So those are kind of the two big areas that I'd say we're working on in this particular space.
So I'll comment on how do we sell this project. And I'll reference Patty's talk on our operation integrity management system. With all our equipment, we define the operating envelopes, and then alarms and alerts need to protect those limits. So part of the justification was simply, you need to do this because it's a requirement as part of our management systems. And also, we mined the databases of unplanned capacity losses, and even just with that data alone, we saw a significant prize being left on the table. Basically, free money, your equipment's not being used to produce oil and gas products. And so even that alone was enough to justify the project. And on the DCS integration side, I would say we're starting to see vendors recognize that alerting technology is coming along and starting to have a separate tab for alerts, and some of the HMI aspects are being improved. And also, we took great effort to populate our master alarm databases, defining is there an operator action for every alarm? If not, why do we even have this alarm? And now we have the capabilities with some of the DCSs we use to show that directly in the operator screens. I'm finding that the operators are now seeing the value of all that work, because it's man-months of work to populate those databases.
Okay. I have a question for Bob and Jeff, actually two parts. The first part is, does your new understanding as a result of doing the analysis find its way back into your basic regulatory control strategies?
Oh yeah, it does. And not only the regulatory control, what we're finding is that it finds its way back all the way in what we call chem synthesis, where we're developing new concepts in chemistry, because we're learning from a manufacturing and execution where we're producing product. What are we learning there in terms of the next product that's going to come down the pipe that we have to produce? So the more insight we get into the process relationships of how we build chemistry, how we make blends, and the impacts that have on the processing, the alarming, whatever you want to call it, how can that feed all the way back into when we're designing processes to begin with? Okay. So it's both.
Okay, Jeff?
Yeah, I'd say definitely when we look at the data and we see operators having to make lots of manual changes, there are certain loops that need to be tuned better. And we also have, a lot of our models are specifically looking at valves, whether it's a level control, flow control. So we definitely have alerts and that the operators can take action on, as well as once we see that if there's a certain valve that needs tuning, that type of information is a notification that we provide to an engineer.
Okay, and from your answers, I would assume that your work is fed back into a continuous improvement operational excellence program. Okay.
I just have kind of an observation, which is, we've talked about this, been going on for a while, and actually I think, I remember the first program trying to do abnormal event stuff I was involved in was literally like 25 years ago. And the financial driver has always been the reduction of unplanned downtime or incident avoidance has been a big thing in the continuous industries. In the batch industries, it's increased understanding of what's actually going on inside the batch relationship, being able to steer the batch. But I think what we're seeing more and more is a third big driver, which is tying into the theme we talked about the last couple of days, and Jeff touched upon, and that's trying to capture the knowledge of the experienced people that are going to be fleeing these plants, that were there when they were built, that have been running them for 20 or 25 years, that have these wonderful inference engines in their own heads, about how all this stuff is correlated and what affects what, and trying to get that out of there and get it captured on a piece of paper so it's repeatable and other people can take advantage of it. And that's I think that's more and more becoming a big driver for doing these compared to the historical driver of just the unplanned incidents and the downtime. I don't know, maybe you guys want to comment. Jeff, you already did kind of allude to that a little bit, but.
Yeah, it's definitely one of our drivers, the graying of the workforce and trying to capture their knowledge. And some of the younger operators love these systems because they're connected to everything, and so they love having this advance warning when something's going to occur, because nobody wants to be on the shift when a significant abnormal event occurred. So they see this as helping their work.
Yeah, agree fully as well. I mean, we're constantly looking at the median age of our operators, plant by plant, and seeing how that's shifting. And like many of the companies out there, it's shifting to a younger workforce. There's advantages to that, but disadvantages as well. It ties into my earlier comment in my presentation, where a lot of what we're doing with everything that we're doing with data is knowledge. We don't want things to be black box, even if the black box works perfectly. We want and need people to learn from the process, especially newer people coming in, because they don't have that base fundamental understanding of the chemistry and the process like some people do that are retiring. So how are we putting systems in place to allow them to learn on an ongoing basis? And knowledge capture, knowledge transfer is very important.
I also mentioned the conundrum of automation, because as the processes get better well controlled, you get less experience actually dealing with abnormal events. So that's a kind of a plug for some of the dynamic simulator systems that help. And you can put operators under stressful environments where they're getting a lot of alarms or alerts, and they can practice those situations.
I agree fully. The training, we're trying to get very creative to how to do that in a simulation mode to see how people react to it. I mean, we talked a lot about empirical type of data analysis and everything we're doing. Don't forget first principles. The fundamental, simulation or fundamental studies is very important to complement with all of that, and then really learn from that to allow people to utilize it.
Yeah, I'm actually based in the research and engineering organization. So yeah, we see ourselves as power users of these tools. And a lot of the sites, they'll be thinking about the simple alerts, but we're trying to think ahead. What is that next level of information integration that we can provide? Because everyone's saying all this data is there basically, and now it's just a matter of mining it and picking it, but not overwhelming your users. So we got to be very selective in terms of what information we provide. If these smart valves provide 80 new parameters, we're not going to give the operator 80 new alerts. We need to pick a couple that are the ones that they can actually take action on.
Yeah, same in Lubrizol. We're trying to move these same approaches to be used commonly at all layers as well. So the chem synthesis, when the chemists are out there with their little glass speakers, that somehow they're already thinking in terms of S88 for the operation phase and steps that go into the plant. No, we're not there yet, but we're trying to move in that direction. And then similar systems, applications, tool sets, the architecture to be the same in R&D, pilot plant, scale-up, manufacturing. If we're on common platforms, it makes it easier to share this information and data and get it back up into R&D and get information back down to the plant too.
Gary Lipson from Ashland. I guess with all that we've heard, trying to take the alarm management process down to the plants and have them own that. Usually you end up with a champion at the plant that's your key to making that work. And if they're good, they're going to move somewhere else or retire or wherever. They're not going to stay there. That presents some challenges for the sustainability of these types of programs. What do you guys find as ways to institutionalize that and make sure that it doesn't disappear, that you don't have the hard work and the basics fall apart, that now your tuning's off or your alarm rationalization isn't done and the operators just get fed up with the fact that it's not working the way that it used to and nobody's babysitting it the way they need to?
Yeah, you made the comment champion. Can't emphasize that. You need a lot of champions out there. It needs to be part. You need a core base, and you need, at least in Lubrizol, we had to form that core base. It's not down to one person. One person can get it going, but it's not sustainable. For each of these key topics, we really try and target an individual at each of the facilities to really take ownership locally and then bring that forward. We tie it into what we call our PCM process at times within the Lubrizol. It's performance career management, to make it formally part of their job description, yearly evaluation, have it part of what their goals are for that year to help move it along. That helps it keep sustainable. And then we work with the Human Resources Department at our sites too, that if someone is going to be moving into a new role, which always happens, that we have some type of overlap, cross-training, and the new champion is designated to come in.
I'd like to reference another quote, I think it was from Patty, that she basically said, we measure it, we manage it, and we improve it. So defining some good KPIs, and then so you'll be able to see whether your system's being sustained properly. And because we have so many sites, we can see what best-in-class performance is, and so we can target helping those sites that are kind of lagging. And as well, ExxonMobil makes a large commitment to training our folks, and so we've put together either computer-based modules or face-to-face training sessions so we can get the users up to speed and so they can become power users as quickly as possible.
All right, Richard, do you have one last question?
I was just wondering if you talked a lot about bringing in continuous process information, but if you've been able to integrate the discontinuous, like the equipment history, work orders, and the people that are actually on the shift or the conditions that are around the operation as well to the alert system?
In Lubrizol, we have not done that yet. I would call it more of like the text-based, unstructured type data, where it might be information that's being recorded, if I understand your question correctly, like in logs or observations. That work we plan to get at later on seeing how can we extract information out of the text-based information to couple it with the more tangible type of measurements that are occurring. As far as maintenance, I think you mentioned we are trying to couple more and more with that, because the maintenance information couples a lot with the performance and health of the equipment, which then couples back with whether it's reading correctly, calibrations are correct, and it reads, feeds back into the variability of the process and ultimately the quality. So we are linking maintenance data and maintenance information in that context along with the other pieces of information to put into context so that we could quickly diagnose. So again, based upon maintenance records, we have different types of assets out there, different models and vendors that are used on different manufacturing processes, all of which have variability in quality. So is quality being impacted based upon the types of devices that we're using and how calibrated they are? So we're linking those together. Excellent.
Yeah, I'm not sure that I totally heard the question, but our definition of alerts was around what can the operator solve on their shift. So when we're going through and trying to think of new alerts or new rules and models, sometimes we come up with things that are beyond a shift, and so we'll try to send those. Maybe it's a system engineer that needs to look at a log file, or a maintenance engineer that needs to schedule a heat exchanger cleaning or something like that.
Yeah, I guess what I was looking at was when a pump comes back after maintenance, it's in a running condition. So when a pump comes back, it's in a run-in condition, so you know that it's going to be at risk to infant mortality failure. Versus if it's been running for 6 months, you also know it's maybe about to run into the end of life on its operation. So you have a different state that you can apply different rules to.
I see where you're coming from. I think I see where you're coming from. Yes, it's like the as is, or as found, as left, but also the difference between was the pump replaced or was it serviced?
Right.
Because that has an impact on its lifespan and longevity. So we're trying to get our hands around that data more so to come into the predictive aspect in order to proactively work with the information to predict failure, to prevent it. And work with that coming into the context of what was done to that pump from a servicing. Was it inspected and it was fine, didn't touch it, or was it replaced, or was something done to it, and have that come into the database relative that it could be used in the analytics for future prediction.